Alright, now we're doing part B. We need to find the domain. So we know we can't put a negative number or 0 into a log function, so we know that x plus 1 must be greater than 0, so x must be greater than minus 1. And the domain is equal to all values of x where x is greater than minus 1. Now, already this implies to us that we've got a horizontal translation going on here, because the vertical asymptote is going to be at x equals minus 1. But anyway, going on, the range will be like it is for any log function, all values of y. So y is an element of R. Alright, we want to find the vertical asymptote. Well, the vertical asymptote will occur when x plus 1 is equal to 0. So therefore x is equal to minus 1. And any axis intercepts we need to solve for when across the x-axis, when log to base 3 of x plus 1 is equal to 0. So that gives us x plus 1 is equal to 3 to the naught, which is just 1. So x plus 1 is equal to 1. So x is 1 take 1, which is 0. So in this particular case, the x-axis intercept is 0, 0. So of course the y-axis intercept is also 0. Alright, we want to sketch this now. We know that the vertical asymptote is at x equals minus 1. And you know, we can see that because of the log x plus 1, there's a horizontal translation going on of 1 unit to the left. And we saw that in class. So it's no surprise that the vertical asymptote now is not the y-axis, it's 1 unit to the left of that at minus 1. And we could have just sketched it by looking at this point here. Normally the function would go through there, the log function, at 1, 0, but a translation of 1 unit to the left means that it's at the origin there. And we discovered that algebraically in part 2. So that means we can sketch this function in just like that, passing through the origin. And that's the graph of y equals log to the base 3 of x plus 1. It's just the graph of y equals log x with a horizontal translation of 1 unit to the left.